Hello, guys. Good evening to all of you. I welcome you all in this wonderful session. So, guys, if you remember, we are coming up with these sessions for the ISRO examination, as you are already aware. Please let me know, am I properly audible and visible to all of you or not? Yes. Please let me know, am I properly audible and visible to all of you guys? So, we will be starting this session, guys. And today, the session is related to production. And we will be having approximately 25 to 30 top questions for production. Okay. So this session is going to be very helpful for ISRO exam because we are taking up the question of the ISRO exam level and you will enjoy this, guys. This is my detail. You all are aware. My name is Dheeraj Sardana and this is all other details. My expertise, SOM, TOM, MD, production, industrial. This is my teaching experience and my achievements. Let's start, guys, without wasting the time. So as you know that uh, in production, I am also including the material size part. So material size plus production. So this session have both of these. So the very first question is coming in front of you from material size only. Yes, dear. Yes, good evening, dear. Good evening. So this is the very first question in front of you. The very first question says the structure of austenite is it BCC? Is it HCP? Is it FCC? Or it is BCT? So what is the right answer for this question? Okay. So chess chips is saying the answer is CFCC. So very good, dear. Your answer is correct. C is correct answer. So I would like to say, like, whenever we are talking about the iron carbide phase diagram, there some terminologies comes into picture. Like the very first, we also are aware of ferrite. So when we talk about ferrite, we are having austenite. So when we are showing this is alpha ferrite or delta ferrite, and we are also have this gamma austenite. We know that this delta ferrite, alpha ferrite, these are basically coming in iron carbon diagram. But when we are talking about the pure form of iron, then it is alpha iron, it is gamma iron. So you are aware that alpha iron is having BCC structure, gamma iron is having FCC structure. Okay. And if you are talking about BCT, this is the structure of martensite. So I have covered four questions in place of one. So if any other thing is also asked from you, you can very easily do this. Okay. So let's move to the next question, guys. The next question in front of you is also from the material size. It is a very good question. Try to solve it, guys. And do share the session with others because these sessions we are coming up for your benefits only. And I would also like to tell you guys, if you are interested in paid courses, and resultant for ISRO paid courses as well as test series is also going on. So for ISRO, we have already launched a test series, which is of very minimal cost. Okay, I feel it is around 400 rupees. So you can purchase that test series from the resultant mechanical app. Okay, where we are going to provide you approximately 35 tests. Okay, it will also be having the PYQs, previous year questions of ISRO. Okay. Fine. Test chips is saying the answer is C for that also. So dear, the question is doubling the frequency of current in an induction hardening. You know, when we are talking about the processes in material size, if you remember, there is a process called as surface hardening. Okay, so I am having a small discussion of some basic things which will also help you. So when we are talking about the surface hardening, it includes some processes. If you are aware of, one is carburizing, है ना? One is carburizing. Then you are having night riding. Then you are having cyaniding. है ना? And similarly, you are having the induction hardening and yes, induction hardening process is there and flame hardening process is there. So when we are talking about induction hardening, It is governed by an equation that is x is directly proportional to rho by mu f. If you are talking about x, x is the depth, whatever the surface hardening depth you are getting. Rho is basically resistivity. Mu is permittivity. Okay, sorry, permeability. Mu is permeability. Mu is magnetic permeability. If you have studied magnetic field, you would be aware of one thing is known as magnetic permeability. So it is magnetic permeability. If you see rho is electrical resistivity, okay? And if you are talking about the F is the frequency basically. So you can see X is inversely proportional to square root of F. So if you are going to double the frequency, so what is going to happen? You can understand it is going to reduce the depth of hardening by a factor of root 2. So this is a new type of question, and if I tell you this is the PYQ of DRDO, so there are fair chances that it can be a question from ISRO as well. So be ready for that. Let us see the next question, guys. Moving to question number 3. So this question is a very good question once again. So you can see the question states when a uniaxial tensile load, this is our question number 3. When a uniaxial tensile load is applied to a rod fixed at one end, we are having a rod fixed at one end like this. And we are going to apply a tensile force P over it. This is the longitudinal axis. The question says both engineering stress and true stress in the rod depend on the type of material of the rod. Engineering stress in the road depends on the type of the material of the road, but true stress in the road does not depend on the type of material. True stress in the road depends on the type of material of the road, but engineering stress in the road does not depend on the type of material. Both engineering stress, true stress in the road does not depend on the type of material. So let us see how many of you gives the right answer for this. Gokulan, hi dear, how are you? कैसे हैं आप? So please try to solve and answer these questions. You will be getting a lot of benefits from these sessions. Do like and share the sessions, guys, so that you get benefit. Yes, everybody, okay. Just Chips is saying the answer to be D. So, dear, I would like to tell you here how you shall think about. You know the expression for engineering stress is force but a area. Here, there is no factor which includes the type of material. So whether it is a mild steel bar, or it is a cast iron bar, or it is aluminium bar, or it is brass bar, the stress is independent of the material. Which stress? Engineering stress. Engineering stress is not depending on the material. But here, when you write the expression for true stress, it is engineering stress into 1 plus engineering strain. And engineering strain is engineering stress upon Young's modulus, which is definitely depends upon the material. So I would say that engineering stress in the road depends on the type of material. No. True stress depends. Yes. So if you see the answer for this question is true stress in the road depends on the type of material, but engineering stress in the road does not depend on the type of material. C is going to be the right answer for this question. I feel everybody understood this. Let us move to question number 4. This is once again, we are reaching to the casting. Chaplets are used in the mold form, enhancing the rate of solidification, providing additional metal to the casting as it shrinks, carrying off gases produced during casting, or providing support to the core. What would be the right answer for this? Yes, 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 yes. Very good. Chest chips. So what would be the answer, guys? Be fast. To like, share, and subscribe. Very good. Chess Chips is saying the answer to be D. What about others? The answer, dear, is correct. D is the right answer. No doubt about that. So when we are talking about this question chaplets, actually there are some words which are confusing. One is chills, one is chaplets, है ना? So when we are talking about chills, chills are used to improve the solidification. They are actually used to avoid the production of secondary dendrites. But chaplets are to support the core because whenever we are going to have a hollow casting, for making a hollow casting, we are going to put the core inside. So when you put the core, molten metal will apply the buoyancy forces. So to save the core, we provide some metal pieces, which are known as chaplets. So providing support to the core. Is it clear? Yes. So answer is going to be D. There is one more thing that is core print. Core print is the seat of core. This is said to be core print. Okay, so this seat of the core is known as core print. So core print is different, core is different, gills are different, chaplets are different. So this is going to be the story. I feel everybody understood. I feel everybody understood. Yes, let's move further. So guys, answer is D for this. Moving to question number 5. Once again, question is from casting. I feel everybody will be able to answer this time. So dear, as I said, at resultant mechanical or resultant mechanical app or resultant mechanical app, the test series separately for ISRO is also available because there were many students who were saying, sir, we just want the test series. So for them, we have launched it and already one test is available. FM and we are going to add every day one test. Tomorrow you will have a test of SOAP available. After that you will have a test of production available. So one by one tests will be coming. PYQs will also be available. It is at very nominal charges you can have it. Keeping the surface, those students who are preparing for HPCL test series is also live. Keeping the surface area constant if the volume of a casting is doubled. By changing its sign, the solidification time is expected to increase by a factor of. Dear, you are aware of by Chivoridov's law, solidification time is volume but a surface area ka square. So you can say if surface area is constant, it is square of volume ka directly proportional. So according to that, what do you feel the right answer will be? Please try to answer. Okay, Satyam is saying answer is C. Chess Chips is saying answer is C. You are correct, guys. C is the right answer. Very good. Very good, Satyam. Very good, Chess Chips. Okay. If you have not downloaded resultant mechanical application, do download it. Link is there in the description. Question number 6, guys. When the molten metal is poured in a mold, it may pass through the following items in sequence. So what is the sequence in which the molten metal flows? Sprue runner gate riser, runner sprue gate riser runner sprue gate, or gate sprue riser runner? What should be the correct sequence, guys? What should be the correct sequence? Yes, very good. Every student is saying the answer to be A. A is the correct answer. So, dear, if you remember, we are making the diagrams like this. First, this is sprue, this is runner, this is gate, this is riser. So, molten metal is coming from here. So, obviously, A is the right answer. Moving to question number 7, guys. Okay, leave this. This is the question number 7. Which of the following statement is true for a cold flat rolling process? Which of the following statement is true for a cold flat rolling process? Option A, both front and back tension reduce the roll force. Second is front tension increases the roll force and back tension reduces the roll force. Third is both front and back tension increases the roll force. Fourth is back tension increases the roll force and front tension reduces the roll force. So what do you feel the right answer will be? What would be the right answer for this question? Which of the following statement is true for a cold flat rolling process? So dear, if you remember, we are going to have the rolling process. We are having material like this. Here we have the rollers like this. So obviously, this is known as back tension. This is known as front tension. So how it should impact? Okay, chest chips is saying the answer to be B. So dear, I would like to say that whenever you are going to apply the front and back tension, this is sigma back, this is sigma F. So you know that roller are trying to compress it. Okay, so roller are trying to compress the cross section and these tension are going to increase the length. So if it will increase the length, it also will try to reduce the cross section because you know whenever we are going to apply tension in one axis, it create compression in other axis. So obviously, because of volume constant in plastic deformation, volume is going to be constant. So if you will try to increase one side, other sides will get compressed. So the point is obviously as front and back tension, though both are trying to increase the length. So obviously they will be helping us to reduce the force required at rollers because they are also doing some work which rollers have to do. So answer is going to be B for this or A for this. Both front and back tension reduce. Obviously, A is the right answer. So not B, but A is the right answer. For this, I hope chess chips understood. Answer will be A for this. A is the right answer. Very good, guys. Moving to the next question. Next question is question number 8. This is from extrusion. If the extrusion ratio is 20, the percentage reduction in the cross section area of the billet after the extrusion will be. What will be the answer? Extrusion ratio. You know extrusion ratio. It is always bigger. Okay, this you can see is 20. It is original area by final area. It is given as 20. And they are saying what will be the change, reduction. Reduction in area means what will be A naught minus AF by A naught into 100. That is what they are asking from us. I feel very easily you can try this. Try to solve it, guys. Okay. Satyam have already answered it. You can also write it as 1 minus AF by A naught into 100. You know, AF by A naught is 1 by, so 1 minus 1 by 20 into 100. It will be 19 by 20 into 100. It will be 95%. Answer is 95%. Question number 8. Now we are moving to question number 9. In a straight turning operation, if the depth of cut is doubled, then uncut chip thickness will be. If depth of cut will become 2 times, what will be the uncut chip thickness? T1. T1 is the uncut chip thickness. Okay. Yes. So you are aware that whenever we are talking about this, you know, this is in orthogonal, we were making it like this. But when we are talking about straight turning operation, if you remember, this was uncut chip thickness T1 and this was T2. So answer for this is A. When depth of cut will be doubled, then in turning operation, because you know turning operation, I should make it like this. This is orthogonal machining. Orthogonal turning is this, like this. So here, you know, this is going to be our cutting tool. So if it will be orthogonal, you know, it will be like this. So if you remember, it will be having a relation in such a way that if D is becoming 2 times, T will also become double. Answer is A for this. Moving to question number 10. Try to solve this, guys. For a single pass turning process, this is a question from economics of machining. For a single pass turning process, for which of the following, okay, for a single pass turning process, for which of the tool life decreases with increase in cutting speed? The optimum cutting speed for maximum production rate is. So, dear, if you remember, we are having this type of graph and this type of graph. This was the optimum speed and this was the maximum speed. Maximum speed is for maximum production. Optimum speed is for minimum cost. There were two criterias. And I told you we shall operate in this range. So they are saying for a single pass turning process for which the tool life decreases with increase in speed. Tool life decreases with increase in speed. You can see here tool life decreases with increase in speed, then increases, first decreases, then increases, then here increases, here decreases. So where tool life decreases. Here on y-axis we have tool life. So tool life decreases in two regions. Tool life is decreases either here or here. So either before V optimum or after V maximum. So what should be the answer for this? Always more than the optimum cutting speed for minimum cost criteria. Obviously it is going to be more than this. So answer is B. Always less than the optimum cutting speed is wrong. Always equal to the optimum cutting speed is wrong. Less than the optimum cutting speed is wrong. So answer is going to be B. Okay, because they are saying less than the optimum cutting speed for minimum cost criteria if the tool cost is very high. Okay, so answer is going to be B for this. Everybody got it? Tintu, we are running only for mechanical and civil. We don't have electronics branch at resultant. So we run only for mechanical and civil for the timing. In future, let us see if EC will come. The process in which the material removal rate is governed by Faraday's law is electrochemical machining, electro-discharge machining, abrasive jet machining, or laser beam machining. Which of the process uses Faraday's law? Yes, chess chips, Tintu, Satyam, Gokulan. This is an easy question. I hope everybody will be able to answer it. Satyam is saying ECM, yes. So if you remember, Faraday law governs electrochemical machining. Faraday law governs electrochemical machining because in electrochemical machining we study that the weight or mass is directly proportional to, है ना? We study this. It is directly proportional to what? Directly proportional to Q. So, or I. Q or I. Yes, it is Q. Then you were writing it W is equal to ZIT. है ना? This is in grams. So then Z you were writing at E by F. E for electrochemical equivalent or chemical equivalent. F is Faraday constant. Everybody, you remember that. ECM is going to be the process which is governed by Faraday's law. Don't get confused over this. Now the question is from metrology. We are having question number 12 now. This was 11. Moving to question number 12. We have total 25 questions. What would be the answer for this, guys? 20H7G6. 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 Yes, try to solve it. Yes. Okay. So, dear, first of all, we make the basic size line, and this is our 20 mm. This is our H type of hole, and this is our IT7. I feel everybody would be aware of this. Then we have G. Here it is G type of shaft. This will be IT6. So you can see there is a clear gap between H and G, which is indicating the clearance fit. Very good, guys. You guys have done it correctly. Jasyam, Satyam, everyone. Answer is correct. Answer will be A for question number 12. Moving to question number 13. This is once again from metrology and inspection devices. ISRO do ask question from here. An optical flat measures the flatness of a surface by using the principle of dispersion of light, interference, total internal reflection of light, optical contour projection. What do you feel the right answer is? Yes, dear, optical flat basically uses the principle of interference. Answer is correct. B is the right answer, guys. Wonderful. Moving to question number 14. Once again, this is from surface finish measurement. Surface finish measurement. The peak to valley surface roughness in a machining operation is 32 micrometers. Assuming that the surface roughness profile is triangular, the center line average surface roughness is. Yes. What would be the answer? If you remember, average surface roughness is defined as maximum surface roughness divided by 4. Here, maximum surface roughness is peak to valley height. What would be your answer? Everybody. Yes, yes, yes. Obviously, you just need to do 32 by 4. It will be 8 microns. B is going to be the right answer. Question number 14. I feel everybody understood this. Moving to question number 15 guys. 10 questions are still there. After this, which of the following is a correct statement about spot welding, seam welding, friction welding, and roll welding? All are fusion welding process. Dear, fusion welding process are those where workpiece also melt. All are solid state welding process. Here, workpiece do not melt. Seam welding is a fusion welding. Other three are solid state. Roll welding is fusion welding. Other three are solid state. Yes, guys, what should be the answer for this question? Yes, everybody. So, dear, if you remember, solid state welding. Yes, here if you see, guys, actually the spot welding, seam welding, these two processes are coming under resistance welding, which is a fusion welding process. Friction welding and roll welding, they are solid state. So obviously, seam welding is a fusion process. Roll welding is fusion, no. All are solid state, no. All are fusion, no. So actually, this is also not correct because spot welding is also coming under resistance welding. But okay, the best proper answer, if we see, it is going to be the best of all because it is also a PYQ of DRDO. So some questions I have taken from ISRO, DRDO, Engineering Services PYQs as well. Moving to the next question, guys. This is question number 16. This is the temperature employed in brazing. What will be the range of temperature in brazing? Below the melting point of metals, above the melting point of metal, below the melting point of filler material, same as those employed in the soldering. If you see this question, guys, so if you remember in soldering and brazing, in soldering, we heat at less than 427 degrees Celsius, here more than 427 degrees Celsius. But in both the cases, it is going to be below the melting point of the metal. Both the cases. It is below the melting point temperature of the metals for sure. Is it clear? Yes. So answer for this is going to be A. That's the correct answer. Moving to question number 17. Okay, let us go to some different questions now. Next question which I am going to show you is this. Question number 17. In orthogonal machining process, the shear angle decreases. If you remember shear angle is phi. So shear angle decreases if tangent phi is r cos alpha by 1 minus r sin alpha. So you know if cos alpha will be more, phi will be more. If sin alpha, if it is going to be more, from here also you can see, or you can also see from Lee and Sheffer theory, sorry, from Merchant's analysis also you can check. 2 phi plus beta minus alpha is pi by 2. From here also you can check. What should be the answer, guys? Yes. Anybody? Okay, dear. So let me show you. Actually, when we are talking about the shear angle relation, what is actually happening? What do you feel? Rake angle increases when you show it like this. This is tool. This angle is rake angle. This angle is shear angle. Okay. So generally rake angle increases when the shear angle will decrease. Okay. If you see, this is basically the case of positive shear angle. If I show you the case of negative shear angle, then tool will be like this. Sorry, not negative, positive rake angle and negative rake angle. This is negative rake angle. If you remember, this is going to be rake angle now. Okay, this is going to be fine. So it is rake angle increases when you have a decrease in the shear angle. Moving to the next question, guys. Question number 18. When we are talking about MRP2, this is basically the question from industrial engineering. When we talk about MRP2, what is the meaning of M here? It is material requirement planning, manufacturing resource planning, man requirement planning, or money requirement planning. If you remember, there is two MRP, MRP1, MRP2, and then you have ERP. So here MRP1 is material requirement planning, MRP2 is manufacturing resource planning. So answer is going to be B for this. Okay, I hope everybody is getting it. Now we are going to reach to next question, question number 19. The cutting tool that performs orthogonal cutting is it twist drill, broach, helical milling cutter, or single point cutting tool? I feel everybody can answer this question. Question number 19. Yes, Satyam, what do you say? Question number 19, what do you say? Orthogonal cutting is performed by twist drill, broach, helical milling cutter, or single point cutting tool. I feel everybody is clear about this. Yes, single point cutting tool. Very good, Satyam. Answer is correct. Moving to question number 20th. For the fixed cutting speed, when the positive rake angle of a cutting tool increases the tool life. So if you remember the graph for tool life and alpha comes like this. Initially when alpha increases, cutting tool is becoming sharp because of its tool life increases. And once we reach the maximum value after that, after this alpha optimum, if you will further increase, the tool will become so sharp and weak that it will itself get broken. So that's why answer is first increases then decreases. Answer is C for this. Question number 20th answer will be C, guys. So we are left with five more questions. I hope everybody is getting it. Moving to question number 21, and the PDF of this session will also be available on the Telegram channel Mechanical by Dheeraj Sardana. The nature of directrix required to produce cylindrical surface in the lathe is. So if you remember, There is one directrix, one generatrix. So if this generation will move in this direction, it will give you a cylindrical surface. So answer should be straight line. So I feel everybody is getting it. D would be the right answer for 21st question. Yes, Satyam, are you getting or not? Satyam, chess chips, Tintu. Okay, good. Moving to question number 22nd. Near a plate of 25 mm thickness, we are having a plate of 25 mm. Is to be drilled at a feed rate. At a feed rate. There is a drill which is rotating at, sorry, moving at 0.025 mm after every revolution. Feed rate. Time is 20 seconds. Find out drilling speed. If you remember the machining time formula, it is L upon Fn. This is L, this is F. We need to find out N. This is given as 20 seconds. 20, length is, frequency is 0.025. We need to find out N. N will be coming out to be 300 RPM. Got it? Sorry, 3000 RPM. Yes, everyone got it. 3000 RPM is going to be the answer. Moving to question number 23, guys. In ultrasonic machining, the property which contributes to better performances for ultrasonic machining. You know, ultrasonic machining is using what? It is basically using the of hardness of what? You are going to have a slurry. In the slurry, you add some particles of silicon carbide, tungsten carbide. So you are going to put some particles, yes or no, in the slurry. So these particles hardness is something which is going to cut the material. So answer is hardness. Because electrical conductivity, magnetic permeability, thermal conductivity are not going to be used in USM. They are going to be used in ECM and EDM. Okay, so they are going to be used in ECM and EDM. Here hardness of cutting tools, or you can say the edges of the grit particles, grains is going to be the important thing. Abrasives, yes. So we are talking about hardness of abrasive particles. Moving to question number 24. Higher material removal rate with good surface finish in the electric discharge machining can be achieved with high current, high frequency, low current, small pulse duration, high current, large duration, low current, high frequency. So dear, when we are talking about high material removal rate, you know, for that we need more frequency. And when we are talking about EDM, we are majorly interested in the voltage, not current, because it is a high voltage, low current process. So answer is going to be what? Answer for this is going to be D only, because in EDM we require high voltage, low current. So EDM is high voltage, low current process. And ECM is low voltage, high current process. Yes. Next is question number 25. The incorrect guideline for good gating system is The riser volume should be sufficient for compensating the shrinkage in the casting. Less pouring time contributes turbulent flow in the mould. Long pouring requires high pouring temperature. The molten material in the riser should solidify in the beginning. Which of the following is not a correct or incorrect statement? Yes, match, match hub, satyam. What would be the answer for this question? Question number 25. Okay, the answer is D. The molten material in the riser should solidify. Actually, it should solidify in last. That is the main point for design of riser. So answer is D for this. Moving to question number 26. The casting defect which is not caused by high pouring temperature of belt is not caused. Cuts. Cuts are not because of high pouring temperature. Other three are because of high pouring temperature. Next is which of the following material cannot be heat treated? If you remember, I told you low carbon steels generally can be done only with surface hardening process. Other processes, it do not give response. That's why we call it as mild steel. So mild steel, the name itself is because it do not give response to the heat treatment process. Only surface hardening process can be done on this. So answer is D for this. Okay. Last question. Which one of the following statement is true about the dislocation mechanism in the material? This is material size. Elastic and plastic deformation correspond to the motion of large number of dislocation. You know, dislocation movement is known as slip, and slip itself means plastic deformation. So elastic cannot be correct, elastic cannot be correct, elastic cannot be correct. Answer will be B. So with this, guys, we will be closing this session and goodbye for today. B is correct answer, and we will be meeting again every week. I am coming up with one session with one subject. In the next week, I will be coming up with the subject of SOAP plus machine design. Be ready for that. Next week, 30th June, I will be coming. In between, you will have the classes of Suraj sir or Vikas sir for other subjects. And once again, I am reminding you that you can join Udaan batch, Udaan Pro batch, or test series. So they are available for ISRO preparation. Even if you want discount on the gate batches, you can directly connect with us. We will definitely be providing you. HPCL test series is also available. Do remember you can download the Resultant Mechanical app to get all the courses, and for discount you can separately connect with us. So goodbye and good night. Let's meet in the next session.